friends, welcome back to the channel Learn with Art. Now today's topic is NFA with empty moves. Okay, so before going to learn what is meant by NFA with empty moves, up to this video we have seen that NFA or any finite automata is not moving from one state to other state by following empty transitions. Means if we apply empty transition to any state, then it will remain in same state. Okay, so that was the case in the previous type of automatas. Okay, but now in this type of automata we are moving from one state to other state by following empty transitions. So the name is given as NFA with empty moves, or we can call it as empty NFA also. Okay, so the NFA can be extended to include the empty or null transitions like our normal transitions. Okay, so here we'll take one example. Okay, so here we have alphabets as input, that is 0, 1, 2, as well as empty. Okay, so what we have done here, we are moving from Q0 to Q1 with the help of symbol empty. Again we are moving from Q1 to Q2 with the help of empty input. Okay, so this means what? We are moving from one state to other state by following empty transitions. Okay, so we'll take one example for the string, that is 0, 0, 1, 2 string. So if we supply 0, 0, 1, 2 string to this empty NFA, then how it will be processed in this empty NFA? So this will be given as input to state Q0. At Q0, this will read 0. Again, it will move to right by one cell. Now next input symbol is 0. So it will again read 0. After that, it will have the next input symbol as 1. Okay, so in between this 0 and this 1, we don't have any input as empty explicitly, but it can be considered as Q0 empty Q1. So it will automatically read empty from Q0 to Q1, and it will read 1. Again from 1 to 2 it will read empty, and it will reach to state Q2, and it will read this 2 at Q2 state. Okay, so this means how it will read: 0, then 0, then empty, then 1, then empty, and 2. Okay, so this is one of the important type of finite automata, that is nothing but empty NFA. Now we'll see the formal definition of NFA with empty moves. Okay, it is similar to our normal NFA, excluding the one point, that is nothing but transition function. Okay, so suppose we consider, let M be the machine of empty NFA, and this will be defined with the help of again 5 tuples. Okay, so M is defined with Q, sigma, delta, Q0 and F. We already know the meanings of this all tuples, that is Q is nothing but the finite set of all states, sigma is nothing but a finite set of input symbols, delta is nothing but a transition which maps Q to the sigma. Here we have explicitly included empty in the set sigma. Okay, so here Q applied by sigma union empty gives out 2 raised to Q. Okay, so it is NFA, that's why the output is 2 raised to Q. Means for every NFA the output is 2 raised to Q, that is nothing but power set of Q. Okay, again Q0 is nothing but initial state, and F is a finite set of accept or final state. Okay, so suppose we consider example. Okay, so previous example, that is Q0, Q1, Q2 are the states, and 0, 1, 2 are normal alphabets, and empty is explicitly added alphabet. Okay, so up to this NFA with empty moves, we does not include empty in the alphabet set. Okay, but now here we have explicit column for empty symbol. Okay, so these are normally written as capital Q set will include Q0, Q1, Q2. Sigma will include 0, 1, 2. Q0 is Q0 because Q0 is the initial state. F is set Q2, okay, because Q2 is final state. Now here this is transition function, that is delta, okay. So here Q0 applied with 0, Q0 applied with 0 remain in same state, that is Q0. Again we have to write it in curly bracket because this is a kind of NFA only, okay. Now next Q0 applied with 1 gives out no transition for 1 at state Q0, so it is 5. Again same for 2, no transition for 2 at Q0, so again it is 5. Now next is empty, so Q0 applied with empty gives out state Q1, so written here as Q1. Same is the case for Q1 as well as Q2, okay. So this is nothing but the formal definition of NFA with empty moves, or we can say empty NFA. Hope so you have understood the basics related to empty NFAs. Thank you very much.